Okay, hi guys. So in this question, no, actually in this video, we're going to be solving 2.20. Like in the last video, we solved 2.19. If you don't know it, please check it out. The link is in the comment section. Determine the magnitude and direction of the force resultant again F1 plus F2 plus F3 of the forces in a particular sequence. First add F2 plus F3, then add the results to F1. So I'm going to be using the parallelogram method again, just like I did in the last class. So first, we're going to add F2 and F3. The resultant will be approximately around here. Actually, it won't be FR, sorry. It will be FR, as you can see here. So we're going to draw the parallelogram in this case. Now let me just bring it out so that it's going to be clear for all of us. You understand what I'm choosing to draw the Cartesian first before doing everything. So this is F2. This is F3. This is their parallelogram. Now the resultant force F bar is somewhere along here. Its degree is going to be from the horizontal to where it is. Be bar because it's not the main theta yet. So this is going to be 20 newtons, this is 15 newtons. I would like to use this triangle. You just feel free to pick the triangle you want, Mess around and find out. So let's pick this triangle. Okay. This is 15 newtons. It's actually wrong to not be drawing the direction arrows. I noticed I don't do that, and that's not good. This is going to be 20 newtons. This is going to be theta. It's going to be phi. So we need this particular angle to be able to carry out cos rho for this. So let's find a way to find this particular angle. Interesting. This one's a bit tricky for me to get. So if you know the angle from here to this point, then you'll be able to get the angle from here to this point. And then by rule of parallelogram, the angles adjacent to each other must equal 180. So from this point to this point, we can get it. They gave us here as 20 degrees. If you say 270 minus 20 degrees, because from the first quadrant to the third quadrant is 270 degrees. So 270 minus 20 degrees, 250 degrees, which means from here to this point is 250 degrees. Sorry, my pen is soaking. Next, to get this point to this point, we can simply say 360 minus 250 because the entirety is 360. 360 minus this point will simply now give us this point that we want. So it's going to be 360 degrees minus 250 degrees equals to 110 degrees. And this point is 110 degrees. And I told you the parallelogram rule, angles adjacent to each other add up to become 180. So 180 minus 110 degrees is equals to 70 degrees. Therefore, here is 70 degrees. And we have gotten 70 degrees. I know this is a bit tricky. So now let's just apply cos rule. Get slightly bit. This F bar. We are simply going to draw this. Is multiply, square the sides and add them up. Minus 2 times the sides. Cos the angle directly opposite F bar, which is 70. Resolve this and you can get that F bar is equal to 47.07 newtons. Now to get theta bar, simply use sine rule. That'll be 20 over sine theta bar equals to 47.07 over sine 70 degrees. Make theta bar subject formula and you're going to get a theta bar is equals to 23.53 degrees. Okay, so now let's add the results that we're getting here to F1. The resultant force is still going to be somewhere approximately at this point where I initially drew it. So we're going to resolve this so that we can see. It's going to look something like this. F bar is going to be such a downward slope like this. Yes. So let me draw it out. So we're going to draw the parallelogram. This is going to be our F1. And this is going to be our F bar. This F1. Next, we're going to draw a parallelogram. Very sloping. It's going to be our FR. FR has a direction, theta. This is the main theta, not theta bar. Next, I am going to bring out a certain triangle. I believe the triangle I want to use is the top one. So I'm just going to simply bring it out. That is this FR, F1, and this simply the triangle joining. This side is going to be F bar. Now, we don't know most of the angles here. We don't know the angle here. We don't know the angle here. And these are the two most important. Now, in order to find the angle at this point, because that's the most important for the cos rule, I'm going to simply, this is at this point, I'm going to find what this angle is. And from the last question that we solved, this was theta bar, which was given to us by 23.53. So we know the angle from here to here. How? We're given a small cage triangle, which was 3, 4, 5. Now to get the angle from this point to this point for F1, okay, it's already there. It's going to simply be, let's call it alpha, equals to tan -1 of what is the y component of F1, 3 over 4, the x component, which is equals to 36.87 degrees. Then now to get the degree from here to this point, we can simply just see 180 minus 36.87 degrees, which is equals to 143.13 degrees. Now, for parallelogram, two adjacent sides, that is this point now and this point, must add up to 180. We know from here to here is 143.13 plus 23.53. If we simply do 180 minus the addition, that's the entirety of that angle, we're simply going to get 13.14, and we can put that at this point. You can actually go online now and just check supplementary angles in a parallelogram, or angles adjacent to each other in a parallelogram, how they work. So at this point we have 13.34. You're going to simply use cos rule to solve this out. That is, FR will be equals to the square of the sides. F bar is 47.07 square plus F1 is 30 square minus 2 times the sides plus the angle directly opposite to FR. If you type this in your calculator, you're going to get that FR is equals to 19.2 Newton. Now for the theta, we're going to use this second triangle. I'm just going to bring it out. This is FR. This is F bar. Yeah, this is FR. This is its small angle, theta. Let's bring it down here so we don't get confused. And this will be F1. You can see it's parallel. Lines are parallel. Just the same. I'm going to find, we already know the angle from this point to this point, 23.53. We know the angle from this point to this point, so let's just put it as phi. So if we can get the angle from this point to this point, we can simply say 23.53 minus this angle to get theta. So we're just simply going to use the sine rule to solve this out. We're going to have FR, which is 19, that's at this point, 19.2. Well, I'll use the approximate 18 over sine 13.34, which is the angle directly opposite to it. 13.34. Reason being, in a parallelogram, angles directly opposite to each other are equal. You can just pause the video and go and check it out on Google. Now equals to this angle, which is going to be 30, which is f1 over sine of this phi. Phi, if you make a substitute formula, is going to be equal to 21.15. Now simple to get theta, simple can say 23 minus 53 minus 21.15 degrees equals to 2.37 degrees. Now we have gotten the angle of direction for the resultant force and the resultant force itself. Thank you for listening. Anything that wasn't too clear or you couldn't understand it, please do not hesitate to ask in the comment section, and please like and subscribe.